We are missing Bailey. I think we'll just use the dice. That'll work good enough. So when we roll the dice, the first number will be me counting 1 through 6 this way. Second number is 1 through 6 this way. You guys are kind of 6.
1 through 6. Can I do it?
Titus has pretty much ruled himself out for rolling. Is there anybody here who has not rolled before? All three? You're not. Really? All these people haven't rolled? Oh, shoot. Let's just go with closest number. 1 through 6.
3.
4. 5. 6.
Somebody else answered 2. Yeah. 2? Somebody else had their hand up at 5 as well. Reese.
1.
It is 1. You get to decide which number is first. Okay. Okay, Reese, who do we got?
3, 1.
Nobody.
Okay. 5, 3.
Also nobody.
Okay.
You have a town.
3, 6.
Still nobody.
Okay.
Wait, 3. Oh, shoot.
2, 1.
Henry. Titus.
Huh?
You cannot roll that. It's not a possible roll. And you can't, you gotta learn how to stop saying that. Listen, I'll put it this way. 6, 7 has gone on long enough that adults are making jokes of it, which means it has gone beyond your guys'. Like, that means it's already past its prime.
I should say 41 instead, right?
Sure? Just as meaningless as 6, 7. Okay, Henry. Okay, let's start by graphing the line 2x minus 5. You can just tell me how to do it?
Go down to -5.
Good. Go down to -5 to start. Come on, screen. All right, I have a point at -5.
And then you go up to 1.
You need to explain that one slightly better.
Up 2 over 1.
Go up 2 squares to the right 1 square. When you say over, that could be either direction. Okay, and then if you want to repeatedly do up 2 to the right 1, you can, to make like a better line, because trying to draw a straight line sometimes goes very badly. Okay, we've got a straight line-ish, straight line-ish. Reese, I need somebody to tell me
4, 3.
Quint, is the point 2, -1 a solution of that line? That sounds like a guess. Oh, what would we expect a solution to look like on a graph? Oh, does anybody know that answer? It's not wording that I'd usually use. Correct. Every single point that is drawn on the line is called a solution. The way you can check is if I put the point 2, -1 in place of x and y. Okay, so 2, -1, if I want to verify, on a picture it's super easy. You just look. Like if the point 2, -1 is on the line, it's a solution. If you have an equation, you can put the numbers in. And then if both sides equal each other, it's a solution. In this one it does. 4 minus 5 is -1. So that would tell us 2, -1 is a solution. Again, I haven't really called them solutions because haven't really needed to, / the way we've been using them hasn't needed a name, right? Okay, well, I guess I'll ask B, even though the person should know the answer. It's just bigger numbers that you can't see on the graph.
2, 6.
That's you.
Oh.
Reese, the point -17, -39, how would I find out if it's on the line or not? Because I clearly cannot see that on the graph. What would you do to figure out if it was on the line?
Yep. You put -39 to the x variable. Into the y variable.
You put -17 in place of x,
Oh.
-39 in place of y, and if both sides equal each other, it is a solution. We're not gonna do the work on that one, because I just did the work for 2, -1 to show you. It's the same thing. We knew 2, -1 worked because we could see it. Okay, now we're gonna draw another line on the same graph. And somebody's gonna tell me how to do that.
1, 4.
1, 4, who is that? That's Nora. Nora, no matter where you move, you get called on. Are you still trying to verify that you're 1, 4?
Yep.
It doesn't even matter, I called on you. You're the first row, 4th desk from the back. You're 1, 4. Did this ruin your Friday?
Yep.
That's right, I feel good about that. All right, how do I graph -1/2 x? How do I graph -1/2 x? Ooh. You want me to go get a drink of coffee so you can try to find out from people around you? Or like, get help? All right, sounds good. Oh, Landon's just dishing out the help tip. But he's not sending it to you.
Yeah, but I said.
Wow, you're trying to tell Reese how to do it, but not Nora who's supposed to answer it? Wow. Okay, I'll give you a little bit of help. There's no number there, so technically it's +0. So now you have a slope and an intercept. Okay, so +0 means I start at a height of 0. Perfect, the slope would be -1/2, so that means to do what? You kind of motioned it with your finger. Yep. 1 down, 2 to the right. Perfect. I can do that repeatedly if I want, both directions. Good, good, good. Okay, Reese, more questions about the red line.
Okay. 3, 6.
Who's going with Peyton? You probably actually rolled 3, 6. You're getting repeats somehow.
I know.
Okay, Peyton, is the point 4, -2 a solution on the red line?
I don't know that, because I don't know if you found a solution yet. So.
Oh, luckily, we can look at a picture and find the solution. Is 4, -2 on my picture? I think I see it on yours as well. Or unsure? Okay, that's fine. You trying to help? Robin?
Oh.
You had your hand, your arm is like this, so I didn't know.
It is a solution.
Okay, perfect. How come it's a solution?
Because it's on the line.
Because it's on the line. So, if you were gonna plug numbers into the equation, you could do it that way. I think that's what you were mentioning. Otherwise, if you have a picture, you could just look to see if 4, -2 is on that line. So 4, -2 is a solution. And then here comes the important question. Somebody gets the question of the day.
3, 4.
Are you ready for the question of the day? No. Oh dear. Well, you're gonna get the question of the day. Are there any locations that are a solution to both lines?
I don't know.
Oh, I actually think you do know. So, if something is a solution, it's a spot that we can see is on the line. So I'm basically asking you, are there any points that are on both lines at the same time? It's where are you pointing? I know, but that doesn't help anybody. Where are you pointing to? Also true, pointing at the graph, where do they have common points? Where do they both share a point? Oh my God. Okay, do your hand gesture again, which actually is sort of correct for this one. Okay? Do you want some help from Henry? He's trying to raise his hand. Henry,
Is it 2, -1?
yeah. Why is it 2, -1?
Because on the X.
Oh my God, that's way too long an explanation. Somebody should be able to give me a super fast answer why 2, -1 is a point that they share.
It's where the lines cross.
It's where they cross. Wherever the lines cross means they have answers at the same time. The point 2, -1 is a solution on both lines. We are literally going to just be looking where they cross. That's going to be called a common solution, a simultaneous solution, or a solution to the system. All terrible terms, but that's what they're called. In our packet, it's going to be written as a solution to the system. So a system of equations means that you have more than one equation. So if we wrote down these two equations and we were trying to find common answers, common solutions, we would just look to see where they cross. So in our case, they cross one time. Reese?
4, 5.
4 or 5. Titus is very disappointed.
Yeah.
Maybe because his number is so close to the number in his dear in his heart. It is not 4, 1, it's 4, 5. Titus, can you think of two equations that would never cross?
2 equations that
I don't want specific equations, just tell me what two lines that never cross, what would they look like? Yep, parallel. Yep, yeah, I mean, you did it correct with your hands. Parallel lines would never cross. So if you have parallel lines, they would have no solutions in common. The worst one, because on that box, I think the next one says infinite solutions. Mine's kind of cut off, is that what it says? Okay, can anybody think, without rolling somebody, can anybody think how you can have two lines that would have an infinite number of solutions in common?
Like that.
I think you mean correctly, what are you trying to?
Like, the lines are in each other. Like,
Yes,
yeah.
if you have two equations that are directly on top of each other, like they might have different numbers, but they're on top of each other, they would cross everywhere. Those are going to be the three different things that can happen. So if I were you, what I would start with is next to characteristics of systems, I would write how that can happen. One solution means they cross once. Infinite solutions are two lines on top of each other. No solutions, parallel lines. Jason, what are we doing on the Chromebook?
Oh, I just have it open.
Huh.
I'm not doing anything.
Okay, there we go. See, she knew what I meant.
What about their Chromebooks too then?
Yep, they're also gonna be.
I'm just. Alright.
Yours was the most obvious. I don't know what to tell you.
What?
They're
Okay.
hiding behind people.
But Nora wasn't.
Bro, why you calling me up?
I
We weren't behind someone.
Mm.
I'm just saying what I see. And I'm saying facts. That's bars, that's bars though.
Upper glass and three.
Poor Tyson getting picked on.
They're bars though. Oh, Nora actually it worked.
So odd.
Okay, on the homework. Reese, roll somebody, last person.
Alright, last person.
Oh, I keep thinking we're getting done at 15 today, but no, it's a regular
4-3.
4-3. Quinn, oh, Quinn already went.
Yeah. 5-2.
Where's you gonna go, Jersey? Jersey, we went over this already, but I also think that some people didn't get it at the time, so I wanted to make sure to cover it. Question number 1 says, you've got two equations. How would you check to see if 6 - 4 is a solution to both? The word system means both.
If the lines like cross.
So if we were looking at a picture, they would cross. So theoretically, you guys could draw a picture and just see if they cross there. I was looking for a different answer, even though yours is still correct. Do you know the other answer? Courtney, do you know the other answer? Somebody knows the other answer? Rowan, do you know the other answer? I see. Amber, you know the answer.
Wait, what?
How do I check if a point is a solution without looking at a picture? That would be a picture.
Like
Oh,
divide-
wait. Divide?
Like divide it or something?
No, I don't.
Divide what?
That's wrong. It's wrong. That's wrong.
Put the
Oh, man.
We put the coordinates into the equation.
Put the x and the y from the point into the actual equation. And if the numbers work, it's a solution. If the two sides don't equal each other, it's not a solution. That's how you tell if it works or not. If the two sides equal each other, that works, that is a solution. If the two sides don't equal each other, it's not a solution. So for number 1, you're going to put 6 - 4 into both equations. And if both of them say yes, then it is a solution to both. If either one is no, it's not a solution to the system. The word system means, is it a solution to both? So you have to check both. That's number 1. Number 2 is from the picture. I think you guys definitely seem a lot better at doing it by a picture than with the actual numbers, and that's fine, but still gotta be able to do both. Okay, so for the homework for today is just this page. It's, if you have this down, it'll go fast. If you don't, that's no problem, like, we just want to try to ask questions to figure out how. I just wanna start this next topic, gently. So we're doing just a couple questions.